I'm going to talk about the Pythagorean and negative angle identities with respect to the secant, cosecant, and cotangent functions. Okay? I'm going to assume that you're familiar with the corresponding identities for sine, cosine, and tangent. All right? If you're not familiar with those, I would encourage you to watch my video on those identities. Okay? So let me start by writing out the Pythagorean identity for sine and cosine. And notice something interesting. Suppose we divided both sides by sine squared theta. Okay, now suppose we used what we know about the definition for secant, cosecant, and cotangent to express this identity as follows. Okay? So what we do is, what just happened is we created the corresponding Pythagorean identity with respect to cotangent and cosecant. Okay? Now, suppose that I divided both sides of the original black identity by cosine squared theta. If I did that, I would get tangent squared theta plus 1 equals secant squared theta. Okay, so if you don't see how that is equivalent, work it out, divide each term by cosine squared theta, and see how you can convert each term into either the number 1 or a different trig function. Okay, so now that gives us another Pythagorean identity with respect to tangent and secant. So I would encourage you to memorize these identities. You can memorize an equivalent form, whatever you prefer. For example, maybe you like to have the 1 by itself on one side of the identity, so you can memorize. In other words, you can memorize the following versions. That's fine. Cosine squared theta minus cotangent squared theta equals 1, and secant squared theta minus tangent squared theta equals 1. All right? So write those down somewhere, commit those to memory, and we'll be using those a lot. Okay? Now let me talk about the negative angle identities for secant, cosecant, and cotangent. Now, hopefully you know about the corresponding negative angle identities for cosine, sine, and tangent. I'll write those down right now. And remember that one way to see why these identities are true is by thinking about these angles expressed as central angles of circles centered at the origins of XY coordinate planes. All right, so we know that the secant, cosecant, and cotangent functions are reciprocals of these functions, okay, of the cosine, sine, and tangent functions. We also know that when you take the reciprocal of a number, you don't change the sign of it. So hopefully that can lead you to see that the cosine identity that I have written there implies that the secant of minus theta is equal to the secant of theta. All right, and furthermore, hopefully the sign identity helps you to see that the cosecant of minus theta is equal to minus cosecant of theta. And finally, hopefully the last black identity helps you to see that the cotangent of minus theta is equal to the minus cotangent of theta. So write these down, and we will be using these a lot. Okay? Now, let's do some exercises. Suppose we wanted to calculate the secant of minus pi over 4. We can immediately replace that with the secant of pi over 4, or the reciprocal of the cosine of pi over 4. And so that would give the reciprocal of root 2 over 2, or simply root 2. All right? Now, would you please evaluate the following expressions: the cosecant of minus pi over 4 and the cotangent of minus pi over 4. You can pause the video now if you like. Okay, I'll go ahead and work these out. So the cosecant of pi over 4, that's equivalent to, the cosecant of minus pi over 4 is equivalent to minus the cosecant of pi over 4, which equals minus 1 over the sine of pi over 4. And the sine of pi over 4 is equal to root 2 over 2. We take the reciprocal and multiply by minus 1, and that gives minus the square root of 2. All right? The cotangent of minus pi over 4, that's equal to minus, the cotangent of minus pi over 4 is equal to minus the cotangent of positive pi over 4, or minus the cosine of pi over 4 over the sine of pi over 4, and that is equal to minus 1. Okay? Now, here's another type of problem you can do with these identities we've been talking about. So how about this one? What are all the possible values of for the tangent of u where the secant of u is equal to 3? Okay, so here is one way that one could solve this question, answer this question, solve this problem. So we know that the secant of u is equal to 3, and we further know that secant squared u minus tangent squared u is equal to 1. So therefore, the tangent squared of u is equal to the secant squared of u minus 1. So the tangent squared of u is equal to 3 squared minus 1. And the tangent squared of u is therefore equal to 8. And that implies that the tangent must be equal to plus or minus the square root of 8, or plus or minus 2 root 2. Okay, those are the possible values for the tangent of u. Okay, now let's close with a similar exercise, and let's have you try this one. what are the possible values for the cosecant of w if the cotangent of w is equal to 5? All right, so try to solve that one, please. All right, so I'll go ahead and work it out also now. So we know that the cosecant squared of w minus the cotangent squared of w equals 1. So that means that the cosecant squared of w is equal to 1 plus the cotangent squared of w. So the cosecant squared of w is equal to 1 plus 5 squared, or 26. So the cosecant of w, therefore, must equal plus or minus the square root of 26. All right.